In this example video, we're going to be looking at some inverse trigonometric functions to help us find the values of theta here. The instructions say find the principal angle measures in radians and degrees for each equation. If necessary, approximate to the nearest hundredth. Let's take a look at the first one together. We've got the tangent of some angle is root 3 over 3. So if we want to solve for that angle, we can just use the inverse tangent, and that should give us the angle. So let's take a look. Let's use our handy dandy calculator, and you can see it's already on the screen there. Don't even have to hit enter. That was it's very interesting that it was right there. So the inverse tangent of root 3 over 3 we can see is 30 degrees, and my calculator is in degree mode. So the calculator is nice for this because the calculator spits out answers that are principal angle measures, or they're restricted to the principal values for theta. You could also do this one by hand. It's a little tricky with the inverse tangent here, but we're just looking for an angle somewhere on the unit circle that has a tangent of root 3 over 3. You can guess and check a little bit, but we do know that it's not 45 degrees. You're going to see a root 2 here or root 2 there, or some variation thereof. And so we know this is probably 30 degrees or 60 degrees. We don't even have to look into quadrant 4. You'll notice that the tangent here is positive, and so it has to be in quadrant 1. We don't even need to look at quadrant 3 because of our principal angle measures. So if you take a guess, you could guess, hey, maybe this is y over x, so maybe y is root 3 over 2, and x is 1/2. Unfortunately, though, this gets us to just root 3. We need root 3 over 3. So take those in, and we'll use the reciprocal here. So we'll do maybe y is 1/2, and x will be root 3 over 2. And this one would simplify 1 over root 3 if we rationalize, kind of getting in the business of this other one over here. And that would be root 3 over 3. So this is what we need. The value of y is 1/2. The value of x is root 3 over 2. And so if we draw a quick reference triangle, hope you guys can see that. Hope that's not too small. This is 1/2, this side right here. And this side is root 3 over 2, and again we're looking for this angle here, so the angle would be 30 degrees, same thing we got. Also we need to write this in radians, so 30 degrees is the same as pi over 6. So the calculator did give us a nice answer on this one, but you can also do these by hand if you prefer. Let's take a look at the cosecant of theta, and that's got to be negative 10 over 7. Alright, and with the cosecant here, we need to use our both reciprocal and inverse knowledge. So what we're really doing here is we're taking the cosecant of some angle, and that's giving us negative 10 over 7. So we could write the inverse cosecant of negative 10 over 7, and that should give us some angle. So let's try to see if we could use our reciprocals for the inverses the same way we did with the regular sine, cosine, and tangent. So we'll do 1 divided by, and let's see, a reciprocal of cosecant is, that's right, change the first letter, so sine. And we're going to do the inverse sine of negative 10 divided by 7. We'll see what our calculator gives us. Uh-oh. We've got an error here. Domain issue. Yes, indeed. So let's stop that method. You can see that it didn't work. Our calculator is not liking the inverse sign. It's not something that it can figure out. So let's backtrack. Let's rewrite this one and see if we can use our knowledge in a little bit better way. If the cosecant of theta is negative 10 over 7, then the sine of that angle must be the reciprocal, so negative 7 over 10. Got it. This might work out a little bit better for us, so let's clear that out of the calculator, and now we're going to do just the inverse sine of negative 7 divided by 10. Much better. So, if we write this down, this is the inverse sine of negative 7 over 10 to give us that angle, and the angle will be approximately, let's see here, negative 44 rounded to the nearest hundredth, and we've got 0.43 degrees. We also need to state this in radian measure, so we can just multiply this value by pi divided by 180. We want those degrees to cancel out. And you can see we're left with approximately negative 0.78 radians. And you could put RAD here if you wanted, or if you leave it blank, if you don't put any unit there, we're definitely talking about radians. One last part to do here, part C. See if we can figure this one out. This one looks relatively easy. We've just got a little cosine there, no big deal. So we'll write our inverse cosine. Remember, that could also be written as arc cosine, same thing, of the ratio to give us the angle. So you could do arc cosine of negative 9/5, and that will give us the angle. Our calculator doesn't have that, but I want you to know that that does exist. Let's clear this out of the calculator, and let's do the inverse cosine of negative 9 divided by 5. Oh, we got a domain error. Uh-oh. Well, we can't use any reciprocal functions like we did in part B there to help us. Let's struggle with this a little bit. Let's see what's going on here. Let me try to draw this on the coordinate plane here, and this is going to be, let's see here. We could do x over r. Okay, and it's negative, so let's use quadrant 2. Of course, we need to worry about our principal values. So the x is negative 9, so let's make that negative 9. And we need to draw a triangle that has a radius or a hypotenuse here of 5. You can think about this as being adjacent over hypotenuse if you want. Well, I can't. I mean, I can't draw a triangle that has a hypotenuse of 5 and an x value of 9, or in this case, negative 9. It's not possible to do that because the adjacent side right here, if we try, maybe we draw a triangle here, we know that in a right triangle that this r here is going to be larger than the x. And so this is a situation here that just cannot exist. So we need the cosine of theta to be somewhere between, let's go negative 1 and 1. And the reason being is that x over r, or adjacent over hypotenuse, this leg will always be smaller than the hypotenuse. So we're going to have a smaller number over a relatively larger number, and we will never, there's no situation here that will work that work that will get us to something more than 1 is what I mean to say. The numerator is always smaller than the denominator, so in that case we will not have any value that is bigger than 1 or less than negative 1. We could say that this one is undefined or no solution.